Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on October 22nd, 2025. This paper came out just yesterday. The standout result is a hybrid attention design that cuts long context inference cost to 1/10 compared to a 32 billion parameter dense model. The paper is titled, Every Attention Matters, an Efficient Hybrid Architecture for Long Context Reasoning. And as we'll see later, the implications for scaling context are significant. Beyond that, Ring Mini Linear 2.0 and Ring Flash Linear 2.0 pair linear and softmax attention, while an FP8 library boosts training efficiency by 50% and stable reinforcement learning keeps state-of-the-art reasoning. Also, the author shared the code on GitHub. You'll find a library of high-performance LLM training kernels focused on MoE and FP8, with fused quantization and memory-efficient ROPE and QK-norm ops, Triton implementations, reproducible benchmarks, and ready-to-run scripts. There are examples in tests, plus setup, requirements, and docs. You'll find Ring Flash Linear 2.0 weights around 104 billion, Mini Linear around 168 billion, plus a 128K variant, with transformers and SG-Lang quick-start examples for chat generation. Alright, Figure 1 compares Ring Flash Linear 2.0 against strong baselines across 4 benchmarks. The grouped bars indicate parity or small gains in math and coding, which suggests the hybrid attention preserves reasoning quality while slashing long context cost. Codeforce's ELO score uses a rating scale like chess, so taller bars means stronger competitive programming ability. On coding style evaluation, performance approaches about 90%. GPQA Diamond remains solid for difficult science questions. So, Figure 1 suggested the hybrid design kept quality. Table 1 lists the model configurations that make that possible. It distinguishes the mini variant with 16 billion total parameters. Flash scales up to 104 billion parameters. Both keep a 128,000 token context length, which means the models can consider very long documents in one pass. The hybrid ratio indicates one softmax layer follows several linear layers. Mini sets M to 4, while Flash sets M to 7. So Table 1 set the configurations. Figure 2 shows the end-to-end layout that makes the hybrid efficient at long context. On the left, the stacked layer groups repeat M-linear attention blocks followed by one grouped query attention block, which shares keys and values across heads to cut memory. On the right, the yellow panel details the linear attention kernel with QK-norm and ROPE, plus a gate. The figure also highlights sparse mixture of experts and multi-token prediction. Well, Figure 4 shows that decoding memory traffic scales far more gently for the hybrid linear design than for grouped query attention and MLA. This matters because the key value cache, a store of past tokens the model reads every step, often saturates GPU bandwidth during long responses. As sequence length grows to 64,000 tokens, the blue curve stays low, while the dashed orange rises steeply and the green sits in between. Lower access means faster decoding and shorter latency at the same hardware budget, which directly improves reinforcement learning rollouts and chat responsiveness. Alright, 2 takeaways stand out. The hybrid of linear and softmax attention delivers about 1/10 the long context inference cost while keeping strong reasoning quality, and the FP8 fused kernels make long horizon training and reinforcement learning stable and fast. The broader implication is practical, scalable 128,000 token workflows. That is it for the AI Research Roundup. I am Alex. Thanks for listening.